Hi everyone, welcome to Skilled Inspirational Academy. Today's is free CCNA Day 6 class. Let's get started. And before that, yesterday, we got some exercise to do for subnetting, right? So let's first talk about that. If you guys have any doubts, we can discuss in the beginning. And if we are good to go, then we'll follow up with the course content. Yeah, guys, if you have any doubts, you can ask questions now. I hope I'm audible, right? Guys, no doubts for anyone regarding subnetting? So I can take up this as an S and move forward with the concepts. Okay. So today we'll discuss about the difference between TCP/IP and what is OSI model and what is TCP/IP model.
Hi, sir.
Yeah.
Okay, I have one question for that subnetting.
Okay.
We have 8-bit, right? Last 8-bit.
Yeah.
And we have, for example, we have /27. The first 3-bit are network, and last 4-bit are host bit, right?
No, that depends on the first. You have to check what is the range of address. Is it a class A or class B or class C? We got 3 classes, right? A, B, C.
Yeah, that is 192.168.0.0 that we discussed yesterday.
Yeah, that is class C, and the class C, for class C, the default subnet mask is /24. The CADR is /24, right?
Yeah.
Let me open up my whiteboard.
I just want to know how to find how many networks we can drive in this /27 or 24 or 26, 5. We can identify that 2 to power 2 minus 2. That is the how many hosts we have. So how can we identify that how many networks in this?
Yeah, that's what I'm saying. See, if it is /24, so how many network bits by default? How many these 3 octet, right? This 3 octets are allocated for network, right?
Right.
Are you clear about that? Only this octet is for host bits. So we call this as an octet because we got 8 bits, right? In every segment. We have separated into 4 parts, and each part has 8 bits. Are you clear about this? Are you clear with this part? Yeah. So here this is for host, so it is 2 power 8 minus 2. So network is how much? 2 power 24 is your number of networks.
Okay. If it's /27, then 2 to power 27.
No. I'll tell you. See, you have to you have to subtract your actual value with the borrowed bits. See, 24 is the default CADR value for class C, right?
Right.
So if it is /27, so 4 plus X, what makes 27? 3, right?
Three.
I'm
Right.
borrowing 3 bits. So only that you should consider as your network bits, 2 power 3,
Okay.
8 networks.
Okay.
Yeah, you
If
have to subtract with your actual, CADR value. See, if it is for class B, that is different. For class B is a different range, right?
yeah, it's /16. I think 6.
Yeah, /16. So example, if it is 30 is 30,000 example, and the /16. So what happens now? This, if whatever bits you are borrowing, maybe if you want to make this as 20/20, so you borrowed 4 bits now.
Okay, 2 to the
So
power
only
4 is the network.
yeah, 2 to the power 4 is your number of network bits.
Got it. Thank you.
Yeah, if you understood this is pretty easy.
Yeah, I understood that. It's fine.
And if people, maybe you might not have this question, maybe yesterday we've been trying to work out this, right? If I want to chunk this into 8 parts, 8 bits, right? Every bit. So this is something you can, for beginners, that's fine. This is not the actual way of doing, but if you want to know how exactly I derived this value 128, 64, 32, 16, 8, 4, 2, 1. If you need it, you can do a division with 2. 2 on 2, 2 to 4, right? 2, 7, 14, remainder 1. So it gives me 128. So if you further divide this into 2, 6, 12, yeah, 2, 3, 6, and remainder 1, it gives 64, right? And 2, 3, 6, 2, 1, 2, remainder 1, it gives me 32. And 2, 1, 2, 1, 2, 5, 10, remainder 1, it gives me 16. So if you keep on dividing this, 2, 7, 14, remainder 1, this gives me 8. 2, 3, 6, remainder 1, 4. 2, 1, 2, remainder 1, 2. And last is 1. So I got 128, 64, 32, 16, 8, 4, 2, 1. This is for beginners. I mean, you can start with this. I mean, how we this is just, you're chunking this into 8 parts, right? So that's the reason I'm giving this example. So very beginning, if you understood this, then you don't need to do this division method. You can always write down this 8 parts. This is just, I am trying to explain you how I derived this value, 8 parts. It's 128, 64, 32, 16, 8, 4, 2, 1. The same way we got 4 parts, right? It's 32-bit addressing. So everything is a 1 bit. So altogether 8 bits in one segment. 8, 8, 8, 8, 8. So total 32. This is the basic, and this changes for the class A, B, and C. Class A example, if I take a range from class A, it's /8, right? So by default, only this 8 bits is for network. So that's the meaning of this number of network bits. So from this, you can find your subnet mask value, right? If all the values are filled, see, 128, 64, 32, 16, 8, 4, 2, 1. So what do you mean by that? 1, 1, 1, 1, 1. If I want to make it as binary, so all this values are filled. So that's the reason I'm getting 255, right? If you sum up all these values together, I'll get 255. So that's the representation of 8 here. And if I want to make this as 16, so I have to subtract this 16 with 8, because 8 is by default, it's allocated. So the borrowed bits is 8, so it became 16 now. So if you want to find the number of networks in this range, if it is /16, then you have to subtract 8, the actual value, with borrowed value. So it is just 2 power 8. That's your value. I hope this is
Okay.
pretty easy to follow, right? If you still have difficulty, please let me know. I don't have any problem in explaining one more time.
In class C, we can't make a subnet ping for like Celeste.
Sorry, your voice is
So,
breaking a little bit.
means if we are assuming we have one subnet for class C,
Okay.
and can we make it for /20 or
Oh,
because /20 by default?
class C, you mean we should make the same to class C?
Yeah.
You mean to
For
say,
example, we have an IP
okay, it's an
192.168.0.0
so you want to make it a
and
/16. You want to convert this back to
yes,
class
less than 24.
less than 24.
Yeah, we can make it or not. Just
Usually in the traditional practice, I don't think we can reduce. I'll research on this part and I'll come back to you, because we always use 10 network, right? In home, we use 192 range. And why? Because the number of IP address you get in your home maximum 4, 10, 20, but you got 253 valid IP address with the default subnet mask value, right? /24. I don't think I never seen people, going back to the CADR value for a given range. I didn't see that, but anyhow, as I told you, I'll research on this and come back to you with a concrete answer. But for now, I think it's not possible.
okay, but I think in an IP calculator we can do for any IP for any slash.
Maybe, but if you actually see for my piece, let me try. I don't think it's possible. Maybe you get a values, but I haven't seen people using it like that. With 192.168.0.0 and /16, I haven't seen that. But I'll research on that specific your question and I'll answer you tomorrow.
Okay, sure. Thank you. We can proceed now.
No problem. But for now, the basics, we can do all this. We can play around with subnetting, but the basic with the standard ranges, you understood right now how we can do subnetting and what is the rules that should be followed when we do.
Yeah.
How do we find number of host?
Yeah.
The network. Yeah.
Yeah.
Okay. So somebody, they asked me to show the class D and class E, right? Yesterday. So there was a question to show class D and class E. This is class D and class E range. This is mainly used for, for multicasting, this class D, and class E is used for reserve purpose. Can you see this? They said it's used for multicasting. Multicasting is, as I told you, in the routing protocols, you would see this. You got two different routers, and if all these routers are talking to each other on the same routing protocol. The routing protocol I'll discuss later, but for now, if these three, routers has to communicate with each other, and if they're exchanging their routes, maybe they got the LAN like this, right? Every router, it's connected to a LAN underneath. And if it wants to advertise this network information, say for example, this is 10.00.24 and this is 20.00.24 and this is 30.00.24, and it is all advertising its network. So it's saying, hey, this is my network 10.00, and what is your network? So for that, the route exchange, they use a specific protocol. There are many protocols that's called dynamic routing. They call it as a dynamic routing, because whenever you keep adding your networks, and if you have if you build your new network, then automatically, when you advertise this network, this will be dynamically advertised back and forth and vice versa. So in this case, I cannot keep doing this, right? So if there is any specific changes using this multicast address, these three routers can communicate with each other. Multicast is what? One too many, right? So if I am making any changes in this particular router, so by default, it will be relayed back to the multicast address. And from the multicast address, all the other routers will come to know, okay, this is the change. It's been done recently and I have to update my routing table. So yeah, it's many to one generally. So the multicast address are used for these kind of communication. There is some specific address, something like I think it's 224.0.0.9. This is a multicast address used for EIGRP, only by EIGRP, to send the messages to many routers with same routing protocol running on it. Multicasting is one to many. You can make it simple. You can understand. So this is all used for reserved for future use and for research and development purpose. We are not using this this address range ever in the enterprise design or in home networks. Have you ever seen? I think nobody would have seen this IP range in your home networks, right? This is all used for future use and also for research and development purposes. So this is not used in enterprise or at home. So this is of three classifications. We got three types, the IP addressing, and we generally use this three: class A, B, and C. And subnetting is for you got you got 16 million hosts, but we are not going to use that. So based on my requirement, I can customize. This customization is possible with subnetting. So that's how the subnetting comes in, and we are using subnetting to reduce the wastage of IP address. I'll make use of the network, and I can customize my network, and I can design my network as I wish. It's not wasting much addresses and make it pretty simple and align the IP schema as per my requirement. That's the ideology behind subnetting. So yesterday, I think I have given some exercises. I hope everybody would have done that. And if you have any problem, you can ask that. Let's continue with the topic. So now I would like to give a quick recap about the stacking, because I have explained about how the stacking looks, but I couldn't show you exactly how the stack looks in the real environment, right? So a quick recap, and I try to do this in EVNG, but I don't think stacking is possible in any virtual labs. Only with the physical appliances you can do. So this is how your connection should be. If I got two devices, you got two stack ports here. So here you get connection only to send your stack information. Something like if the switch is up and running, it keeps sending it keeps sending a keep alive. Say I'm active. So this kind of messages will be exchanged from A to B and B to A, vice versa. So if this stack link goes down, you will get a notification, and this particular redundant stack port will be active then. And in the stack, one key thing you should understand is there will be one switch that is going to be your master switch always. So that's some kind of MAC calculation it does. Your switch with the least MAC address will become the master. And if the master goes down, this will become active. Also, you can set your priority. So if I make this as a priority 30 example, so this becomes a master forever. So if this switch goes down, definitely there is only one appliance that would be sending all my traffic back, right? So that becomes a master. So all this information will be exchanged on this, the stack ports. So what is the status of my stack? Is it up and running and all that? So very useful command is show switch stack ports. If you give this, you can see it would say it's a stack port number 1, 0, 1, 2, 1. As per the naming convention, you would say, okay, this stack port is, so it will say it is up or down. Same like your interface. So this is, if we got three switches in a rack, so this is how you have to make a connection. See, all the switches should have a redundancy here. A is connected to B, right? And C is connected to B, and C is connected to A. So this is called full redundant connection. So every device has a separate power supply for this device to power up. But what is the use of this stacking? What's it says central management. That's the major advantage of using stacking. Because one common management console. What do you mean by that? Say, if I want to see a port status in this switch, maybe in this switch, fast Ethernet 0/1, the user is connected, the PC is connected. So I can manage this from switch A. I don't want to log into this switch. Got it. The same way, if there is a PC or server that's connected to this switch, fast Ethernet 0/1, I can see from here. But the naming convention is not going to be same. If you make it as a stack, it will be changed. As I told you, the first switch become fast Ethernet 0/1. Second switch it shows as fast Ethernet 1/1, and the third switch is fast Ethernet 2/1. So I'll come to know, okay, this is on switch 3, this is on switch 2, and this is on switch 1. So everything in one single management console, I can manage, and I can configure the ports right from the switch one. No need of jumping back and forth between the switches. So that's the reason of stacking. Okay, then let's move on with other topics. So we have seen, right, what is the need of private IP addressing, because all the LAN networks, right, all your LAN networks, you should use only the private address, not your public address. If this is your LAN, so always it should be private address. Everybody should stick to this rule, and everybody is using it. All your LAN should be using private address. So is it your PCs anywhere using a public IP address? Never, because that's been always assigned with 10 network or 192 network, class A, or generally maybe in home networks is class C, and for enterprise they use class A. And we are also using 172 segment class B also, that can be used only, but your IP allocation should be within class A, B, and C range, not in class E or D or public IP range. So this is the need of private addressing issue. It's used in the LANs. Your public IP should not be used in LANs. There are some exceptional cases, something like if you want to host your network in the internet, that case we use that, but we use a separate concept like NATing. The upcoming classes will discuss about that in detail. So now we'll see what is the key difference between access ports. In access port, it is classified into two subcategories. One is data port and voice port. First, let's see the theory part, and then followed by the practical for data and voice ports. Let me open up my whiteboard and I'll go through the theory part first for what is access port. So first thing comes into mind, why do I need access port? What do you mean by access port? Because I think in a couple of classes before I've done this, but I want to give a detailed explanation because we have gone through what is VLANs, but the access port comes here. What is the use of access port in a VLAN? So if it is your VLAN 10, and you got your switch. There are two types of ports. One is access and trunk. Why do I need that? And what is the use of the access port and trunk port? So access port is always used for PCs, your servers. So how do I call this? Generally they call this as a, endpoints. So all the endpoint ports should always be in access port, cannot be trunk, because it cannot understand. Because only the PC, if you make this PC as an access port, only then the PC can send a traffic back, right? The PC is not like a switch to understand all the traffic. It is just interested about its own local LAN, not about the other LANs. So if it is an VLAN 10, the command is switch port access VLAN 10. If I make this becomes an endpoint port. Only I can connect the endpoint. So here you may get a question. So why do I need a trunk then? Because if I have a VLAN 10 and if I got a VLAN 20 here, how do the VLAN 20 users will communicate back to VLAN 10 users? How the communication happens between these two PCs here? So what happens here? See, if the PC is trying to access a device in VLAN 10, example is VLAN 10 is 10.0.0.2, and this is 20.0.0.3 example, it would say, hey, I'm not this 10 network. I'm not aware of the 10 network. I definitely need a device. I need a help to send this traffic back. They say, hey, it's not belong to my network. So I have to send this to my gateway, and it comes to my gateway, and gateway will check, okay, it's not in my gateway. So there's something in a different network. So let me go open up my, routing table and check, is it in the same network or a different network? No, it's on a different network, right? Because we configure is here SVIs, switch virtual interface. We discussed this earlier. This is, they call it the SVI, switch virtual interface. That's interface VLAN, layer 3 VLAN. So the VLAN 20, it gets this request from 20.0.0.3. If I want to send this packet to 10.0.0.2, so for the first thing happens, so 20.0.0.3 will try to reach its gateway, because I don't know about this network, because this PC is not on the same VLAN 10, right? It's on VLAN 20. So it has to send this information somehow to the gateway. So once it reaches the gateway, the switch, it opens up its routing table and check, okay, that 20 network is directly connected, but I know where exactly I have to send this, because inside my routing table, I am aware about all this information, and I'll forward this information back, and it gets to know about this destination, and the information will coming back here. But here, there should be a specific port. It should allow all the traffic, right? So VLAN 20 will be sent from switch 2 to switch 1, and from switch 1 to switch 2, the VLAN 10 traffic will be forwarded. So if the packets has to traverse back and forth, I should have one common link that sends all the traffic. That's called trunk link. People, they call it as an uplink connection. So this is trunk port, and this is access port. Trunk port is used between the switches and between a device. Not only trunk is used for, switches. There is some specific servers that is also capable of, running trunk links. So it's something, if your end device supports the trunk, then you can make it as a trunk. So what is the ideology of trunk? You're sending multiple VLAN traffic. You're sending multiple VLAN traffic in the trunk. Not about only one VLANs, right? That's a key difference between trunk and access port. So inside the access port, once Cisco has leveraged its access port, Cisco has this feature. See, this is your Cisco switch. This is your switch, and you got your PC. There is a chance definitely in the enterprise network I mean you guys would have seen that. So on top of the desk, they got a laptop and a phone, IP phone. This IP phone is capable of assigned with it gets an IP address like a user PC. And how do I connect for every if I got every, say for example, I got 24 users, so they got 24 laptops and 24 phones. So can I connect 24 laptops and phones in 24 port switch? If that is my limitation, because every switch it costs very high, right? I cannot afford as much. I mean, for 24 users, I cannot afford 48 port switch. It's very expensive. So if that is the case, I will make use of one single port for data and voice. How? Logically. So the access port is classified into two types. Okay, one is for endpoint, your PC, and another one for voice, your phones. You can connect. But the command that's used is same command: switch port, access, voice, VLAN 10. Example, if your VLAN, the specific VLAN is assigned for your voice, then this port, this particular access port, if this is your switch and this is your access port, and you are doing this configuration, this specific port, what happens? This port is physically one single port, but logically, it sends traffic for VLAN 10 for voice and VLAN 20 for data. But here, definitely you will get a question. So how come physically I'll connect? So what happens? You from this connection from the switch, you have to connect to your phone. You got two ports here. So here you would see a port for a PC, Ethernet jack. So from here you can connect your PC. So this phone works as a bridge. That's it. It just forwards the packets to the PC. It's not doing any mechanism to differentiate the traffic. So all it does is the port, what you configured here. So it sends the traffic, the phone voice traffic to phone, and the phone is just bridging the traffic back to PC. So it talks on VLAN 10, and this PC be communicating on VLAN 20. We'll see in practical. So you'll understand how exactly this can be achieved. So let me jump into lab. Let me open up Packet Tracer lab. Okay, how do I do that? So let me take a switch. Let me take an end devices, and then let me take IP phone. Yeah, this lightning bolt connector will make an automatic connection. Because we know the difference between the crossover straight through serial cables and all that. Serial cables, as I told you in the day one class, it's no more used now. They're all using fast Ethernet ports. Please zoom in a little bit. Okay. So I am in enable mode, into privilege mode. It's negotiating, right? The switch is negotiating now. Oh, interface brief to see the port status. Let me see, is there an option? The packet tracer to connect RS-232 port, and we got a fast Ethernet port, right? So I'll connect a PC. Okay. So this is how the connection I explained, right? So you got one physical connection. This is my one physical connection that goes to my PC. And from this PC, I got an fast Ethernet port. There I connected my PC. So what happens here, this one single link, this access port, actually forwarding two traffics, right? So as I told you, VLAN 10 and 20. So VLAN 10 is for what? Voice, VLAN 20 for data. It's capable of sending traffic for both VLANs. So once this PC receives this traffic, it strips out VLAN 20 traffic because it's not interested. I'm only interested on voice traffic, and it talks on the voice VLAN and forward this packet back to PC. And the PC is interested on VLAN 20, and the PC will communicate back. Let's try now the lab. So fast Ethernet 0/1 is up and running. You can see this physical connection in this topology. Sync home, zoom in. So is it a phone is somewhere else? Okay, I cannot see that. Okay, this is the port we connected to the IP phone. It's showing, right? The phone is, I think it's very far away. It's not clear here. Let me go configure. First, I have to check this is a L2 switch. We give a version, show version, it's 2960. Let me try to create an interface. VLAN, okay, I can do that. So I'll do VLAN 10. Name, I cannot give the name. We give a question mark to see what are the possible commands I can run. Description, I can give, okay, I'll make it as voice VLAN. Followed by IP address. I'm giving a class A and changing the subnet mask value here 255, 255.255.0. So what is my actual value? Eight. 255, 255.0, it's /24, right? 3824. So I got my subnet mask value. With CIDR, it's reversible, right? From the CIDR, I can find the subnet mask value of the network. So if I give this, you guys think it will work? Bad mask. Why is that? Because .0 is a network address, right? I cannot use this. So I should give a valid host address. So my valid host address starts from 1. I give 1, it works. So a no shutdown. And then I'm creating one more VLAN for data. Description, data, VLAN. So now I created 2 broadcast domains. IP address 20.0.0.1, same 255.255.255.0, no shutdown. How do I verify the VLANs are up and running? I have to give a command show IP interface brief. So both are down. Why? Because I haven't created an L2 VLAN. So I should have both L2 and L3 VLAN, right? Only then it's up and operational. Because how do this know? See, I created a gateway. But what network it belongs to? So my L2 VLANs plus my L3 VLANs together will make it functional, right? So I have to create an L2 VLANs now. VLAN 10. Yeah, can you see this? The port sub and VLAN 20. So how do I verify that? Show VLAN. So I have created this too. And what is the next step? Third thing, I have to assign the ports to the appropriate VLANs. So how do I verify from the remote perspective? I'll give show CDP neighbors. I don't think show CDP neighbors because it's just show me the directly connected devices, but the IP phone is 2 hops away. It's 2 hops away, so it's directly connected as IP phone. Oh, IP phone, the port is still down. Should show me show MAC address table. Not showing me any port. Show MAC address table address. Why is that we have to verify? What is the port that's used? Fast Ethernet 0/1. So what is the status of Fast Ethernet 0/1? Show IP interface brief. It's up and the protocol is down. So what I should do now? The physical link is up. Interface Fast Ethernet 0/1. Switch port access. VLAN 20. So now my PC can communicate, but how do I make the IP phones to receive the traffic? Switch port access. I think the command is not possible with. Oh, sorry. Switch port voice VLAN. You can always make use of this question marks. All your possible commands you can see. So I gave switch port access voice. No, it's actually switch port voice VLAN 10. So now let me check the interface status. VLAN 10 and 20 is still down. And my port Fast Ethernet 0/1 is still down. I have to verify why is that. So I have to give show run command. Switch port access voice VLAN 10 and switch port voice VLAN 10. So let me check the port assignment here. Okay, for VLAN 10 and 20, can I see both ports signed? Let me see why the IP phones is not communicating back. Where do I connect it exactly? It's in Fast Ethernet. What is the remote port it's showing me?
Arjun, sorry to interrupt. So I can see both VLANs using the same port, I guess.
Sorry, sorry.
I can see that both the VLANs are using same port. I mean, say
No, that's the
oh, sorry.
ideology. That's the ideology of connection, right? I think it should be
Sorry.
it should be
Is
powered
it-
on.
Yeah, sorry, I got it.
No problem. I'm actually trying to find a switch here. How do I power on this appliance? Actually, I'm not using much packet tracer. There should be a switch to power on. There should be powered on. Let me try. Actually, it should have a switch. Go to settings, back, I have to connect this module. Okay, but you see lights now. Yeah. Let me check the port status now. Yeah, it's up and running. Now the protocol is up. Let me assign the IP address now. Let me go do an IP configuration on the PC. Let me assign a IP in a range of show IP interface brief. So 20 is my data network, right? So 20.0.0.5. Subnet mask is 255.255.255.0. And the gateway is 20.0.0.1. Just close this and try to ping my gateway. Ping 20.0.0.1. I get a reply, right? So let me open the simulation. So what do I see inside the IP phone? Can I say this? This simulation helps you to visualize things. The traffic is going back and forth from PC to the switch. Yeah, the IP phone is forwarding the traffic for the PC. See, it's successful. One single port, but two VLANs. So now I'm forwarding the traffic for VLAN 10 voice and VLAN 20 for data. Let's check the phone now. We stop the simulation, coming back to real time. Just showing me the display options. This packet tracer option is a little bit different actually. Here we got a CLI to change the, I was using student packet tracer. So how do I configure the IP address for the phone? This is a real troubleshooting. This is how we have to find. There should be an option. It's not configuring an IP address here. Settings, nothing comes in. Okay, let me try in EVNG. Am I learning the MAC address? Yeah, for phone and PC. Can you see this single port? In the single port, I am learning both PC and phone. Okay, guys, for now, let's leave this IP phone. I'll figure out this. So it's a bit different. The packet tracer which I used in student packet tracer, there is an option to configure. This is a little different. I thought it could be the same way of doing, but here the options are a little bit different. I'm not aware of this. So in the next class, I'll show you how to configure the IP address in the phone. But for now, the MAC address, I can see the MAC address of two phones. Only testing that's pending is we have to assign an IP address in the IP phone, and we have to make a communication back. And then the EVNG, I would like to show you, the concepts that we can do only in the EVNG, because this 802.1q and the native VLAN and all that, I haven't tried in the packet tracer. I mean, I tried with the EVNG. I don't think this is supported in Cisco packet tracer. So the next concept we are going to discuss is this is data and voice port. Voice port is pending, as I told you. Tomorrow I'll show you how to assign an IP address for this phone. So data and voice, now we have seen the traffic is going in a single link. The voice testing, we can do it tomorrow. We'll move forward with default VLANs, trunk ports we have seen, and we will see what is 802.1q and native VLAN. So for that, let me see if it is supported in packet tracer. Otherwise, we'll jump onto the EVNG. I have a lab ready there. So I want to connect one more switch. As I told you, I'll do a use case. I got two VLANs. Here I got one more VLAN. If the switch boots up. Okay. Interface. Okay, let me do interface VLAN 40. IP address 40.0.0.1, 255.0.0, 255.255.255.0. No shutdown. And the description is VHR. And then followed by VLAN 50. Description is production. Product. IP address 50.0.0.1, 255.255.255.0. I have to create my L2 VLANs, VLAN 40 and VLAN 50. VLAN 50. Can you same prompt? Straight up. Show the interface brief. Protocol is down. So let me give show VLAN. I got VLANs, but why the protocol is down? Because I do not have any active devices connected, right? Couple of days back, I think we had a topic about this. I said we should have an active devices connected to it. Only then the protocol will be up and running. Otherwise, only the physical link would be up. I got two PCs here. So connect to the switch. Okay, and both ports are up. So I have to check what are all the ports which is connected to. Takes time to learn the MAC address, just it's negotiating. But we know from the physical perspective, it's fast Ethernet 0/1. So interface fast Ethernet 0/1. Switch port access VLAN 40. What are the VLANs I got here? VLAN 40 and 50. So I'll make this VLAN 40. Can I see this line protocol on interface VLAN 10 change status change to up because I got an active port now. And another port is fast Ethernet 0/2. So I will make it a switch port access VLAN 50. Verify that. Okay, VLAN 50. I'm making this as a VLAN 50. So we discussed in the theory, right? So this is on VLAN 20. This is on VLAN 40 and 50. So how this PC communicate back to PC0, that's on 20 network. This is on 40 network. Let's assign IP address. First, let's make the trunk port. So I've connected this port fast Ethernet 0/3. So through auto negotiation, the port is up and running. Interface fast Ethernet 0/3. Switch port, mode, trunk, question mark. Customer port encapsulation, switch port, trunk encapsulation. I think it's not supported in this factory set. Switch mode, trunk. So it's negotiating. Let's verify one more thing. I made this port as a trunk now. It is negotiating this port. I haven't done any configuration, no config. But let me jump into that switch and see through negotiation, it automatically the port becomes trunk. The command is show interface trunk. Can you see this? The mode is auto and the encapsulation is in 802.1Q. So what happens in the old switches? If this is an old switch, so 2960 is pretty recent. If it is on old switches, you have to manually go and enable this .1Q. What is the .1Q? Tagging. So what happens here? I'll make a diagram with two colors. You'll understand. So I got VLAN 40, VLAN 50, and I got VLAN 20 and VLAN 10. So this VLAN 40, yeah, VLAN 40, I'm trying to differentiate with colors, you'll understand. So this, you can imagine every color is an VLAN tag to it. So this 802.1Q tags this as a VLAN 10. And the same way, now this 802.1Q tag this as VLAN 40. So this is something how your outfits have tags with a price tag. The same way in every packet, it adds this header, 802.1Q header, along with, see, this PC 40003 that's tagged with, VLAN 40. It's saying, hey, I am VLAN 40 and this is my IP address. So I am going. So inside the physical link, logically, all these traffics are isolated, not collapsed. Yeah. They are going independently between the switches through this protocol. That's the use of 802.1q. If this is enabled, so your traffic will be isolated. It will not be collapsed. So this is how your communication happens between the switches. And to make it happen, you have to have a trunk port. So this is a use of trunk. And in the old switches, you have to enable this. The command is switch mode trunk encapsulation .1q. You have to enable this command. But if you give switch port mode trunk, this by default enables 802.1q. And how this communication is happening between the switches, because one end it's done for, no, this end is for auto negotiation. It's something, hey, whatever you say, I'll agree. If you say it's an access port, I'll agree access port. If I say trunk, I'll make myself as a trunk, because you are saying you want to be a trunk. You're sending this traffic. That's the reason it's made it as an auto trunk. Let's jump into the first switch where we configured, and we'll try to run the same command here and see what makes do we see any difference here? Show interface trunk, auto trunk. Because if I give configure terminal and interface trunk, it automatically enables 802.1q. And by default, the native VLAN is 1. We have a concept of native VLAN. So I'll discuss about the native VLAN. So what is the IP address that's been assigned? Both are up and running. So now I'm doing a testing from this 20 network. Can I ping 40 network? 40001. Did I assign 40001 as a gateway here? Yeah, 40001. So the traffic is not going. Why? I have to troubleshoot. So can I ping? Okay, I made it as a trunk. So my traffic is, I'm able to reach my gateway. Yeah, but it's failing to send the traffic back to 40 network. Let me see what is the issue. So I got a trunk, I got 2 switches, I got VLANs. And from here, can I ping 20001? So this is this switch. So let me try to ping 20001. Okay, I cannot ping. So what should I do here? Let me do a debug.
Yeah, hi Arjun. I think you need a L3 device for that, right?
No, sir. We got a gateway, right?
Where is gateway?
This is a gateway, right? VLAN 40 and 50. We don't need this is a now you can run the device, right? This is L3 capable. You have assigned an IP address. Now we are trying to find why this communication is not happening. I can reach. See, this is something related to. 1 minute, let me check, sir. Give me some time. I'm looking at it. Let me run the ICMP debug and try to ping in 001. So my traffic is not traversing back on the trunk. So what is the port, trunk port here? Show interface trunk. Yeah, it's showing me a trunk, an auto trunk, and the VLANs allowed is 1, 2. So now, right now, the VLAN allowed are VLANs 1, 10, and 20. So I'm allowing all the ports. So run. So where is my trunk port? Show interface trunk. Fast Ethernet 0/2. Okay, the packet tracer it's not showing. Let me bounce the port. It is shut. No shutdown. Manually do a trunk fast Ethernet 0/2 support mode trunk. Not needed, but anyways, let me try. Show interface trunk. Now let's try to ping from this PC to 40.0.0.1. What is the debug I get from here? I have run a debug. Show debug. It's not working here. Debug ICMP. IP ICMP. Terminal monitor. See, I'm not able to see any logs for ICMP. Show VLAN. So it's fine. I got my VLANs assigned. And my trunk is also fine. Nothing else I need. I should definitely have a connection back. So the trunk allowed or VLAN 40 and 50 and modus auto. Forwarding state, okay. I'm allowing all the VLANs, but why? Just a direct communication. Let me try to reach the gateway self ping. Show IP interface brief. Okay, I can ping 10.0.0.1, right? 10.0.0.1. Yeah, I can ping 20.0.0.1. Interesting. Why is that?
Do we need any default gateway?
No, sir. Here, see, the ideology here is, see, I got a switch here, 2 switches, right? Inside the trunk, whatever the VLANs I have created here, VLAN 10 and 20 in switch 2, and I got VLAN, 40 here. So I'm making it as a trunk. What happens? All this VLAN information will be sent across this trunk. and it will be forwarded back to this device, because since I got a gateway, the traffic has to, traverse between these devices. 1 minute. I think it's the issue here. I think it should be the VLAN mismatch. Because I am running a different VLANs. Let me go jump back to this. Okay, I got it. What's the problem? So what are the VLANs I got here? VLAN 40 and 50. So what is the VLAN I got here? VLAN 10 and 20. Okay. VLAN 10, VLAN 20. So show VLAN, show interface trunk. Let's try now. So IP assigned. $10,001. I have VLAN 10 is allowed now. Show interface trunk pin 10,001. Okay. So VLAN 10, what is the status of VLAN 10? Show VLAN. So it's an active, forwarding the traffic back. We try to face VLAN 10. IP address 10,005 55,000. Let me make one of the port on VLAN 10. I don't think, but still we have this VLANs allowed. 10 and 20, and I got VLAN 40 here. Let me try this traffic. I can reach 10,005. Okay. Let me have one more device. I can ping, right? Yeah, but why I cannot echo send and I'm getting a reachability now? And what is the VLANs I've created here? Okay. VLAN 40 and 50. Configure terminal, VLAN 40 and VLAN 50. VLAN 50 I have to give again, go back and do VLAN 50. What are all the VLANs now? Show VLAN. All I created is just L2 VLANs. And this is a gateway. So what is the IP address? 40,001. Ping 40,001. I can reach 10 network. This 40,001, it's an up and running, and I got a VLAN allowed. 40, what is the gateway I have assigned here? 40. 001, right? Yeah. Okay, I'll do one thing here. Let me create configure terminal interface VLAN 40. The address 40.0.0.6.8. Show history. Show IP interface brief. So my VLAN 40 is up. So let me ping 40.0.0.1. I can reach 40.0.0.1 now. The problem is I haven't, created the VLAN. The VLAN has to match in both devices. Even though being a trunk, I have to, have similar VLANs in both devices. Only then the communication happens. From 40, I can reach 40.0.0.1 now.
Can you just ping from PC?
Which PC?
PC1 to PC0?
PC1 to PC0. Where is this? Is PC0 and PC1. You want to make a communication between these two?
Yeah.
One minute, let me check what is the port status for show running fast Ethernet 0/1 and it's for 40.0.0.1, right? Stop IP config 40.0.0.10 255.255.55.0. Yeah. This is 20.0.0.5. Okay, got VLAN 20 here and I have to create VLAN 20 here. '56. And I should have an active port. So 56, 56 is up and running. Let me go and ping 20.0.0.1. This IP address I have assigned for 20.0.0.1. I didn't have an IP address for VLAN 20 here. Okay. I have to do a port configuration. This is on 40 and this is fast Ethernet 0/2. So running fast Ethernet 0/2, I have assigned VLAN 10. So I'm trying to ping from the VLAN 40. right? Because this is VLAN 40. So if I ping 40,001,
Hello.
1 minute, sir. Yep.
Yeah, can you please try me the switch port mode access? After that, we can try
Sorry.
switch port mode access. I think it works.
I didn't get your question, sir. What's your question?
So can you try me the switch port mode access? After that, we can ping the PC1 to PC0. I think.
We already made the port as access port 40.
Okay.
What do you mean to say? You want to change this to access port 20?
No. Just I want to know that. So we have done right. So
Yeah, we have done that. I'm trying to ping 20 network. 20.0.0. What is the IP address of this PC? 20.0.0.5. Okay, let's try pinging the gateway. Pretty simple lab. 20.0.0.56. Why I cannot ping the gateway?
Can you just show me the PC configuration on IP address which you gave? You didn't give a default gateway. You didn't give a gateway on PC, right?
Oh, yeah. I forgot the default gateway. That's the reason I think, yeah, we had problem. But okay, I missed out any of good catch, yeah. 40.0.0.1. I didn't check that. 40.0.0.1. So what happens now? This since I don't know the gateway, the packets is getting dropped in the switch. $20.0056.
Is it a gateway 20.0056?
Yes, sir. Yep. So this is my gateway 40.0.0.1. I cannot ping 1 minute, sir. 1 minute. Let me check a few things here. Why I can't ping the gateway itself? It's access port 40. It's an access port 40. Fast Ethernet 0/1. Pretty simple. It should go back to 40.0.0.1. And the subnet mask, what I configured for show run. So it's the same subnet mask I'm using here, 5500, and the gateway is 0. I can ping now 40.0.0.1. Okay. Why I can't ping? Because it's both the SVI in the same. It's a VLAN 10 and 20. Show IP interface brief. And my protocol line and protocol both are up, but why can't ping from 40 to, it should reach the gateway and it should reach this gateway 20.0.0.56. All the 100 packets lost. Let me try to do a quick testing here. Let me add one more PC. assigned to this port. So fast Ethernet 0/4. Is it a problem with the packet tracer?
Should I tell something, Arjun?
Yeah, sure.
Yeah, actually, your switch egress interface doesn't know the network for that. So you have to add a L3 device, or if you do a switch on L3 basis, you have to give a default gateway or gateway for that network, right?
No,
After
sir,
that, it
not.
will work.
No.
Is it
See,
is it an
see,
intervalent routing, right?
no, sir. See, all the interfaces is in my gateway, right? This is all my gateways. This is all directly connected. So for directly connected, you don't need a routing at all.
But is it an intervalent routing, right?
Yeah, for interval and routing, I got
You
the
need to-
gateways configured, right? I
You
got the
need,
gateways configured.
okay, fine, Arjun.
See, I got the gateways, right? Here are all my gateways. This is interval and routing, what we are doing now. Because I am specifying the VLANs. And this is a gateway. It is supposed to send the packet back. I'm trying to figure out why it's a bug with a packet tracer. I have to find. Give me a minute. Let me check this. Interface fast Ethernet 0/4. IP address. Sorry, switch port access. VLAN 20. 20.0.0. 20.0.0.57. 55.255.55.0. 20.0.0.58. And now let me try to ping 20.0.0.56. It's my gateway, right?
I think gateway is 56.
Okay. Now from here, I'll try to ping this PC 20.0.0.5. I can ping, but whereas when I try to ping from this network, this is what IP configuration, I gave gateway and all that. But if I try it, okay, let me do this 20.0.0.57. Ping. Why this inter-VLAN communication is not happening here? Just a port gateway. Okay, source 56 and destination. I get a ICMP reply message, but from this PC, did I assign gateway for this PCs? Yeah, I got my gateway. What is the gateway configured here? It's 56. That's a problem. 57 and this is 58, not 58, 56. 56, okay. I'm done. 56. My gateway is 56. 45. Let me try now. This port is on VLAN 20. Fast Ethernet 0/4. Yeah, it's on VLAN 20. up. Protocol is also up, but I cannot reach. Can I reach 56? Oh, we don't not work here. I got this interface. Why is that? It's failing. Not even the traffic is okay. Let me try to ping between the switches. Ping 20.0.0.56. Yeah, I can ping. And there is no source command in packet tracer. Okay. 40.0.0.1. From here, let me try to ping the PCs. 40.0.0.10. Okay, I can ping, but from the PCs, this PC is on VLAN 40. Yeah, it's on VLAN 40. So why this traffic is not going to 20, 56 or 57 then? Even within the switch, this is not communicating to its gateways. Okay, guys, so I'll do the lab in EVNG. I don't think this is a problem. This is a pretty simple design. We got all the gateways in the same switch. Since I have a problem, we have to reboot and try. And I'll do the same lab in EVNG tomorrow. I'll figure out why this happened. Yeah, I'll try to find out this. I feel like this is a bug. I'll confirm that. I don't see any problem with the configuration. This is pretty simple because all my gateways are in single switch. It has to communicate, but there is some problem in the packet tracer, I think so. So let me reload and flush this config and do that, and also try with EVNG, and we'll do a lab tomorrow, same lab. Make it working. Yeah. Okay,
Yeah,
guys.
sure, done.
Yeah, sure,
Okay.
sure. Yeah. So we'll catch up tomorrow. Have a good day.
Okay.
Then. Bye.
Bye. Thank you.
Thank you. Yeah, bye.